Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about data virtualization, delivering next-generation unified access to data, analytics, and insights. And our sponsor today is Dremio. For our presentations today, we'll hear first from James Kobielus with TDWI. And after Jim speaks, we'll be joined by Nick Acheson with Dremio for a fireside chat. Again, today we're going to be talking about data virtualization, and our first speaker is James Kobielus. He's the Senior Director of Research for Data Management at TDWI. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. And over the past 3 decades, Jim has held analyst positions at Futurum Research, Wikibon, Forrester Research, Current Analysis, and the Burton Group. He also served as Senior Program Director for Product Marketing for Big Data Analytics with IBM, where he was both a subject matter expert and a strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, data ops pipelines, and more. Welcome, Jim, and with that, I will hand it over to you now.
Thank you, Andrew. Hello, everybody. I hope you're having a good day wherever you are. So today we're going to be talking, as Andrew indicated, about data virtualization. Really, data virtualization is an established approach for unifying access to data as well as to the analytics and the analytics-driven insights that data can deliver. So data virtualization has been around for quite some time, and it continues to evolve as an approach for unifying access to data across very complex environments. Data virtualization on one level is a way of managing data sprawl, but also it's really an approach for improving accessibility of data and analytics, as well as improving performance on queries and dashboarding and other data and business intelligence and advanced analytics applications, as well as for delivering 24/7 service levels of continuous access to distributed data by distributed users on a continuous basis. So data virtualization continues to evolve. Now, when TWDI research, when we look at data virtualization, which in fact is a topic that we've been covering for quite a while, we look at it in the context of what are the essential pillars of a next generation data fabric. And a next generation fabric is virtualized, and I'll explain what that means. It's intelligent. It's got embedded analytics to drive ever more contextual delivery of insights to various users in various use cases. It's automated to a great degree. The ingest and the processing and delivery of data and insights are automated to a greater degree ongoing. Automation continues to grow in the virtualization fabric. It's continuous in streaming and low latency because business and life operates in real time, and data virtualization fabrics deliver real-time access. And it's self-service. It's an enabler for everybody, whether they be business users or users in their personal capacity, to have self-service access to data, to dashboards, to fast query response, to machine learning assets and so forth across complex cloud environments. So virtualized, data fabric is virtualized. What that means is it unifies virtual access to disparate data, so you don't need to move the data sets, but rather you can provide access to data wherever it happens to sit, as well as to the machine learning and other analytics resources that are being delivered in data from data platforms across a complex cloud environment. So there's an abstraction layer, a virtualized abstraction layer that unifies integration, analysis, and viewing of disparate data across increasingly complex cloud and cloud-to-edge environments. So data virtualization instances run in various operating environments and paradigms, including containerized and serverless and other. So what they do is they enable and deliver programmatic access to distributed data through cloud-native APIs of various sorts. So virtualized, a data fabric is intelligent and leverages artificial intelligence, machine learning tools to power the delivery of contextual intelligence across a complex cloud environment. And an intelligent data fabric leverages data catalogs that are themselves powered by AI and enable a rich semantic layer in order to provide a unified interpretation and understanding and glossaries and definitions of the data that happens to be pulled in from hither and yon into virtualization environments and delivered out to various use cases. So an intelligent data fabric, a virtualized data fabric, supports intelligent cataloging and indexing and search of all data and metadata on a continuous real-time basis. An intelligent data fabric enables tracking of data sets, changing locations, types, formats, and associations, because virtualization environments make the location of data increasingly irrelevant because you have a unified abstraction for accessing and managing data no matter where it is, and it can be moving from continuously around, but you still have rolled up, unified access to it all. And a semantic layer, as I indicated, accelerates search-driven query and analysis of not only data's meanings and context, but data's lineage, its entire provenance, and as well as linkages across disparate data sets. The semantic layer makes all of that quite transparent to the end user. So you always know the status of data at all times, and you know what it means. And data comes from disparate sources and is rolled up into a unified abstraction, a unified data model, thanks to virtualization. Automated, a data fabric is automated. Increasingly, these data analytics pipeline workloads that run over the fabric in a virtualized environment, the ingest and the transformation and the delivery and contextualization, all that is automated. A lot of it is using machine learning-based AI methods that do enable such capabilities as the ability for the virtualization fabric to learn pipeline traffic patterns, to detect anomalous workloads, to manage change data, and to optimize methods for accessing, persisting, and delivering data. So really, as having artificial intelligence within the pipeline, within the virtualization fabric, enables a virtualized data virtualization environment to be continuously self-monitoring, self-supervising, self-healing, and self-optimizing. So AI-driven metadata handling is a key enabler of this automation, and it enables the increasingly growing data workloads to be managed in a hands-off or lights-out environment throughout a distributed cloud. So it's a way of the automation of a data virtualization fabric is a way of enabling greater scaling of your data estate without the need to necessarily have to add on new staff to manage and monitor it all. It's continuous. A data virtualization fabric is continuous. It's real time. It's continuous and low latency. It enables real-time ingest, processing, delivery of data and insights from everywhere in the web, in the cloud. And it enables the downstream applications that can support in-the-moment contextual intelligence from the latest and greatest data and the latest and greatest analytics into every downstream application. So in many ways, a virtualization fabric is absolutely essential to the real-time nature of life as a whole now and modern business within a distributed cloud ecosystem. And self-service of data virtualization fabric exists to unify access to data so that it can be to enable self-service in terms of actual end users who are doing query and reporting and dashboarding and the like, but also to enable self-service access for the new generation of data scientists and data engineers to be able to do powerful things with very intelligent tools to enable them to not only, for example, to build and train and deploy and test and iterate machine learning models, but also to build an increasing number and sophistication of data products using business intelligence apps, data science notebooks, and the like. So self-service in a data virtualization fabric is powered by embedded recommendations, recommenders or recommendation engines that suggest for every task and for every user the most relevant guidance for them in terms of what data they need, what processes need to be performed on it, such as cleansing and and correlation and so forth, to be able to pull the data together, to build and train machine learning models and so forth, everything that they need to do to be able to accomplish some desired outcome with respect to data that is fetched in real time continuously over a virtualized fabric. So self-service. So I'm going to hand it back to Andrew. He's going to introduce our panelists.
Terrific. Yeah, thank you so much, Jim. That was a great presentation, and it is now time for our fireside chat, which brings me to our guest speaker today, who is Nick Acheson with Dremio. Nick is the Field Chief Data Officer at Dremio, and he has delivered digital and technology transformations at massive scale at organizations such as Nike, Zendesk, AEO, Philips, and the NSA. Prior to joining Dremio, he was the CDO at Acheson, which was acquired by Databricks. Welcome, Nick. And with that, Jim, I'll pass it over to you to begin the fireside chat.
Thank you, Andrew. Hello, Nick. Great to have you.
Yeah, no, it's good to be back.
Yeah, I give my whirlwind tour of how TWDI defines data virtualization. And clearly it's a moving target as virtualization environments continue to evolve and change. And one can say that there is a virtualization 2.0 paradigm emerging. So my first question for you is, of course, the level setting. What is data virtualization? How does Dremio define it? And really, what do you see as next for virtualization?
Yeah, no, so I guess first off, I loved your presentation. And I think you know me by now. I get a little fussy on stuff. So I think that's what makes a fun fireside. I think what you presented on virtualization strategically is accurate. I think the thing that we've learned on the practitioner side is strategy obviously isn't always execution, right? So there's definitely things that virtualization got right. And there was definitely spaces that we learned through unintended consequences, right? Where virtualization still needs to evolve. And I think that's some of the stuff I'd love to kind of chat through. But I'd say directionally, you're right? Like, and this is where when I work with most of our clients, and just to note, like even as part of my job, half of every single week I'm on site on whiteboards with, Fortune 500 customers, helping design not just architecture strategy, but also putting that in terms of business impact and trying to connect those worlds, right? So I do deliver insights and transformation, right? Faster, smarter, better. It's always that three of how long is it going to take, how fast to value, right? And when are we going to get there? So, and then how do we measure that? So, for me, I think when you think about virtualization, it's always like virtualization is the first step, not the last step. So, directionally, how do we get value through connecting out sources extremely fast, right, to get that unified access layer? But then there's like the now what? There's always those next steps. And virtualization has left gaps in that architecture, but it's also left opportunities. So I'll probably stop there and say I'll refer to your slides, but let's go.
So what are those gaps? Let's start there. So what are the gaps right now in how virtualization has been done and that virtualization 2.0 and approaches can address? Can you sort of outline the essence of virtualization 2.0?
Yeah, I think there's key parts of it, and then there's the things we learned, right? So the obvious, you covered some of the key parts, but this is also a lesson learned, is the entitlement side, right? So I'd say virtualization can go fast, but most folks know, especially at the enterprise level, when you mentioned earlier, like interacting with data where it sits. Well, unfortunately, most companies still have separate auth-in and auth-z processes, most consistent auth-in, but how we do authorization. Mm-hmm. It's a lot of one-off on a lot of these platforms, right? And how you're running all of your policies are one-off in those platforms. How you do group management is one-off in those platforms. So being able to have consistent authorization across all those different platforms is hard. Oh, yeah. So, building out a proper entitlement service that allows you to consistently do that, so who's interacting with what data, and frankly, not having overprivileged data across your ecosystem, which is a massive problem. Frankly, I think every company has. It's just a matter of like how fast are you addressing it while you're delivering value. The other one, as you mentioned, the metadata side, right, is I think one of the things we learned even in the technology ecosystem, as I use like Airflow, for example. If you want to have lineage and you have Airflow in your ecosystem, I guarantee you probably don't have lineage. Or I guarantee most companies don't even have provenance, but provenance is always a North Star because things like embedded SQL within your Airflow DAG will kill your lineage path, right? And that breaks all of your visualization, even within your catalog, which is how I broke Calibra a couple times in a couple different companies. But I'm still a Calibra fan for terms and glossary.
Well, good, you fixed it too.
So the other one is Malt, right? How do you actually I love Bar over at Monte Carlo. I think she's doing amazing things. But as you do things like virtualization and do multi-joins across different data sets, how are you even monitoring that, right? That output or that data product? And there's not really good answers yet. And I think then that moves even into contracts, right? How do you think about data contracts and even changes of these assets over time? So, there's great companies that are all spinning up to try to address these, right? The platforms are evolving. So I think it's exciting to see how 2.0 continues to evolve, but I'll stop there because I could probably just keep going.
Well, clearly data virtualization is an ongoing project, right? That's different. That project or program is different for every organization, right? Based on it, no two organizations have exactly the same configuration or topology or set of data assets and applications and platforms that need to be connected. So where would one start on a data virtualization project? What's the good step number one?
Yeah, it's similar to the conversation I even have around governance, right? You see a lot of companies that'll start a governance initiative and they start at the enterprise level and then they fail. And normally they fail again until they finally learn of, hey, what are the key initiatives and key priorities that the business is trying to get accomplished? And how can I use virtualization to make that go faster? Right. And I read a pretty cool HBR article actually last night, waiting for a friend for dinner. And it even noted like a CDO that can connect the business directly into the data initiatives delivers the same amount of value at about $5 million less in budget. And does that about 70% of the time.
Whoa.
And it's just like, how do you continue to do that? That should be driving your virtualization strategy. Then as you have virtualized and start pulling people up into that semantic layer, like agnosticating those data sources, that now lets the data teams to actually innovate underneath the covers, right? You finally want to get off Teradata, right? You need to get people out of Teradata. Doesn't necessarily mean the data has to immediately move out of Teradata, which we all know is a massive path. So it's really thinking about things differently and changing the patterns of how people interact with data. And then it allows you now to make the technology invisible and to mature and modernize.
Great. I'll move to the next question, which is almost as basic as the first question I asked, which is, applications of data virtualization. What are those use cases? What are the primary enterprise use cases or scenarios for which a data virtualization approach is best suited compared to, say, consolidating all of your data into a massive data lakehouse? So we often, think of data virtualization as something you do when none of those consolidation approaches is quite right. Is that the way to look at it, or is data virtualization more of a strategic framework that really, in many ways, you should consider a long-term strategy, not just a stopgap?
Yeah, maybe it's more of a yes and answer.
Okay.
So I think first and foremost, a lot of folks will go into the virtualization in that consolidation cost-saving space, to which I'd argue everything you should do in a contemporary world that we're in right now in this economy globally has to have a TCO element into it, right? So, there's a simplification path, but sometimes simplifying actually costs more. So it's really being intentional about what your architecture looks like. But that said, everybody's being asked to do more with less. So as you kind of think about the consolidation and savings piece, then it's more of like, well, how do I still tie that into, because the business is always asking for more, right? Or they're going to ask for more of these great things that you're already doing, which is already stretching your teams out too thin. So in my most use cases, I think there's two consistent use cases that, frankly, I don't care what industry you're in, is probably getting funded. One is that 360 ecosystem, and I don't just mean customer. It's usually where a lot of folks will start, but it's really about what's that next best experience, action, message, product, recommendation. What's that 360 next best for your customer? So Customer 360 is a very easy one to fund when you tie that into the business impact and your business goals, right? Given that continued online offline.
Customer 360 just as effectively with data virtualization as you can say with data warehousing. Is that correct?
So warehousing as a pattern, right? So I think part of the warehouse piece, as we had that promise years ago with Martin Fowler, right? And moving into a domain-driven design and building out, the performance wasn't there. So we kind of shifted back and started doing data marts, right, and data hubs. And we kind of shifted right back into the warehouse because, again, I think the performance wasn't really even there yet. I think the technology is finally catching up to those promises years ago. But the 360s, right, we did the 360s in those spots to be able to meet the demand and performance and started creating microservices across those to connect. But, you still had to create another layer even over that said, when I give this next best offer, which provided in our customer 360 with content 360 with the product, right, to make sure we're delivering the right product recommendation and making sure that we actually have that in supply, right? Nobody wants to be recommended a product that you can't buy. Then the next thing is like, well, what does that mean for things like LTV? And what does that mean for the maturity and changing of a customer over time and changing those recommendations? When someone has a child, you recommend different products to them than they were when they were 16, graduating from, or getting near graduation from high school. So running a continuous experience and how that continues to mature in the ecosystem, that's, again, even multi-layered over top. So I think for virtualization, allows you to get there faster, but you still have to continue to modernize for performance underneath the covers. And that continues to make you look at different platforms as well. So the other one is supply chain, which is, again, kind of the similar to that 360. Everyone's always still trying to break out of how do I get out of my SAP HANA one-off, very big, ugly implementation? That works. It runs the business. But how do I pull that into my 360s? Like making sure you know what's in your four walls, for example, and what your pipeline looks like, even if you're in the biofarm side, right? Everything from pre-manufacturing all the way to post-manufacturing.
Well, yeah, clearly virtualization is suited to a distributed industrial supply chain environment, which pretty much by its very definition is multi-platform on data and analytics and the like, as well as to a front-end 360 customer 360 ecosystem, which often is quite varied in terms of the various platforms, sales and marketing and customer service and so forth, that need to be hooked in to the back-end data virtualization fabric. When you work with customers and help them identify the right applications in their organization for data virtualization, what lessons have you learned, Dremio, in terms of what customers are trying to do? Are they trying to achieve a quick payoff from their investment in data virtualization, or are they looking at sort of like the long haul in terms of return on investment? What lessons have been learned from virtualization in the real world? Where does it break even to implement virtualization in the average enterprise?
Yeah. So there's a couple of questions in there. So maybe we'll kind of work through a few of them.
Sure.
The one is more like on the learn side. So I guess to build on some of my answer earlier, the other one that's clear, especially as folks talk about things like data mesh or fabric and data products, right, is there's a very clear difference, and you need to have a very clear difference between enterprise assets and functional assets, right? And to be clear, like what does it mean to own them? And what does it mean to then also have certified types of assets? Right, Jim, if you're creating your own data product using virtualization to go faster, if we're going to make enterprise level decisions off of that, that needs a different level of respect, right? And I think this is the part of fabric and mesh that I really enjoy, which is everybody, when they hear about data products, they think of that in terms of mesh. And I'm like, yeah, that's a key component. And frankly, almost every company has that now as a functionality. But what does it mean to actually treat data as a product, right? And I think that's the piece of not all products are the same. Just like not all data is the same. And understanding how people can build off of that. How does changes happen, right? I think most of the people probably even listening in here have been woken up in the middle of the night because someone changed the Salesforce definition or logic to a particular field, broke a top 10, if not multiple top 10 dashboards, and it took a day or two to figure out how to fix it. And that type of asset, that's a top 10 asset, that needs a maturity path. So I love a comment Michelin actually made one time when I was chatting with them, was like discipline at the core, flexibility at the edge. So how you think about something being enterprise versus how you think about something being functional, there needs to be a maturity path to it, but you shouldn't slow teams down. Innovation still needs to happen. but you have to define that governance strategy on those assets.
In fact, data products, yeah, you absolutely need data governance to ensure that the data products you're delivering, let's say it's ML, an AI chatbot that incorporates embedded ML, and the ML has been trained from your distributed data assets. Any product you sell, the customer is going to expect an assurance or a warranty of quality there. So provenance and lineage and governance absolutely essential to assure that level of quality, and also to provide the audit trail that the customer might require to make sure that what you're delivering to them is not damaged goods. So I'll move on to the next one.
Let alone the life cycle of that moving forward. Yeah.
Yes. So move on to the next question. What value in terms of the pillars of data virtualization, a semantic layer is very important, as I've discussed and you've discussed. What value can a tightly integrated semantic layer deliver in this environment? Next generation data virtualization. And really, is a semantic layer, is that term subsuming a lot of other capabilities like metadata management and business glossary? And how do you stand up a next generation semantic layer within data virtualization?
Yeah, this is one of those ones I get fussy on, and honestly, I even challenge myself on a lot. It's almost like, how do you actually define a contemporary semantic layer? I think we all kind of agree that in the contemporary world, a semantic layer is absolutely necessary. And if you start at the why, it's easier to answer. If you get into the how, that's when we kind of differentiate between so many different platforms. And I think the why is because we need to get the data and the value of the data into the business's hands as fast as humanly possible. And if we say, well, what does that mean? Well, that means that it's not all interaction at a CLI. It's not all interaction at API to API. It's not all interaction even in the SQL runner, right? We're seeing the massive explosion of things like ChatGPT and LLMs and all that jazz, but the explosion's happening at the writing and just plain language. So a semantic layer that allows you to do that, I think we're going to see at least within the next year or two. It's already becoming a baseline expectation. So if I said, well, what does that then look like? Well, it's also, how do we logically organize the assets we're even talking about? Whether that asset is a table, whether that asset is a table as an output of a model, whether that asset also is a dashboard that somebody can just easily click into from that layer, asking questions and easily navigate. So I think it's absolutely critical and required, because it's not just the analyst interacting with the data for a business user, it's getting the business user in. I don't know if that answers your question fully, but.
Well, yeah, see, it does. The semantic layer is an enabler so that everybody who touches the data, be they business users, be they data scientists, are touching the data and seeing the same data expressing a consistent set of definitions and hierarchies. Fundamentally, then, the data always has a consistent and governed meaning, no matter where it is. Well, the meaning of the data is always crystal clear at every point in its life cycle, no matter what uses are being put to it. So semantic layer incorporates metadata management, and of course a data catalog is a key piece of the semantic layer. Isn't that true?
Yeah, I think ideally, yes. And this is where I go, like, strategy versus execution is hard, because as you open up with virtualization, what most folks find out is it's really hard to actually know what facts are in your business and how you manage how something becomes a fact, right? So I think that goes back to, like, how you think about data products and certification of assets, because I'll tell you, there's not a company I've ever been at, or probably even talked to at this point, that has 100% facts established across their business, or even clear SLOs or SLAs tied to how those facts are established. So as you open up more data, it opens up more complexity. As you open up more sources, it opens up more complexity, because even at those sources, those definitions are incessantly changing. So as I say, it's more about, like, to the earlier point, how we're evolving and how we're continuing to address those challenges versus saying, hey, this is how I've solved it.
Right, cool. So next question is, clearly data virtualization is a lot of moving parts. So what infrastructure and tooling investments are the primary ones that enterprises should be making to implement next generation data virtualization? We've already mentioned a data catalog, semantic layer, other key enablers for next generation virtualization that are important to mention in terms of ongoing modernization projects enterprises might take to get to a full-blown and robust and mature data virtualization fabric?
Yeah, because virtualization's that first step, as I kind of referred to earlier, there's not a whole lot you have to do on the tech stack as part of that first step. It's mostly about what happens next, in my mind. That said, it's understanding and prioritizing those use cases with the performance requirements that you need on that journey. So you can pull in stuff, right, or data events or data sources that are uploaded a couple of times a day, right? The things that you need near real time with high concurrency usage, right, with very large data sets, right? Being able to just tie a virtualization layer, for example, over top of Teradata and Oracle and SQL Server and S3, it's not going to be very performant, right? You'll get insights that you didn't have faster, but you're not going to meet the demands of a near real-time business experience or customer message, right? Or customer recommendation. So it's being intentional about, hey, how do I prove this value of virtualization out fast on this lower hanging fruit that can move the needle for the company and say there's a better way of doing it. And then as you find and prove those things out, you get more trust with the business and you can prioritize those more advanced use cases. That also helps you be able to actually then optimize your underlying infrastructure and move some of that data and help you do that migration. I think as you move into that phase, now it's interesting of how do you think about enterprise level catalogs, not just individual source catalogs. It's how do you think, and again, catalogs is probably 2 or 3 of them. And then it's like, how do I think about curation of these data sets and looking at tools like dbt, but also not getting caught into the mini mart problem, see back to catalog. So a lot of these things are, again, when I go back to evolving, you've got to evolve with the infrastructure and the business case together.
Yeah, prove it out iteratively in your environment. Like you indicated, you may have, if you're a virtualization user, you probably have a complex multi-platform environment. And so your CDO and CTO and your executive staff may want to see, you're going to roll out this capability to bridge and virtualize across all these disparate environments in a way that, integrates closely with those established investments, but also delivers tangible performance improvements in terms of query and reporting and dashboarding and machine learning in your environment. So yeah, the infrastructure and tooling investments you need to make in that journey will you continue to evolve your set of requirements as the benefits of virtualization become shown, demonstrated, as you've been able to deliver on the promised ROI from virtualization. So clearly in the abstract, there's no one, or can be no one clear checklist of things you need to implement at disparate points in time, because everybody's needs and environment are different. So I'm going to move to the next question, which is, and if my mouse will cooperate, here we go. How should enterprises measure the bottom line from data virtualization? Is it qualitative or a bit of both?
Yeah, I think this goes back to, as I mentioned, the HBR article I read last night, and I'll get you the title of that. But I'd argue every single thing your data team works on has to connect back into the business. And more specifically, shared OKRs, right? Everybody has some version of OKRs or priorities across the enterprise, and then being able to pull them all the way up to like tier 1 level initiatives in the company. Everything your team works on has to connect back in. I used to tell my own data product managers and platform product managers that if I walk into any Scrum team that they run, and I walk in and I ask an engineer, do you know what the impact of the work is you're doing? If they couldn't answer it, I will shut it down and put my badge on it. Because that's also the number one reason most data engineers will leave, right? Or analysts will leave if they can't connect their work. That's part of, if you think about virtualization, what value are you driving? If part of virtualization is to deliver a dashboard, what's the impact of that dashboard? Are we making decisions faster? Can we deliver a capability to a customer faster through virtualization? What's that capability? And did you actually measure the impact after the fact? Was it a 3 million uplift or was it 15? If you expected it to be 3 and it's 15, that's actually scary too, right? How are we so far off and what are we learning out of that? Or how can we apply that to the next use case? And it's continuing to kind of measure and be intentional. I've always told my leaders that I've worked for is I don't want to be measured on the output that I'm doing. I want to be measured on the impact. So I think if you think about it that way, to go, if I can deliver 15 dashboards of virtualization faster, or if I can deliver 3 that fundamentally changes not just the business, but how our customers experience us, I'd rather do the 3 all day, every day. And it's easier to measure on the actual impact instead of the output.
Right. Some of those metrics are customer satisfaction, and that's a complex set of metrics. Some of those metrics are time to value or time to impact, also, of course, cost efficiencies and so forth. So clearly, it's a range of quantitative and qualitative measures that come to play, depending on what you're trying to achieve. Yes. Move to the next question. What is the role of data virtualization in a comprehensive enterprise data modernization initiative? Is virtualization a way station on the way to some larger modernization strategy, or should it be part of your enterprise target state where you're migrating to? What are your thoughts?
Yeah,
here?
I don't think there's a talk or a meeting or otherwise that I probably don't say. No one funds architecture, and if they do, it's one of the first things cut. Right? So I would say if you're modernizing for what? Right? And I think, so I usually say virtualization is just the first of a phased approach. And most companies live in these, the 2 phases I like to say of that. Hey, can I connect to data? And then can I optimize my architecture and ecosystem to deliver that data, insight, or outcome faster, better, smarter, cheaper, right? So it makes it easier now to move the team on to the next thing. Now, I say there's a third step, which is now moving into a modern open architecture, lakehouse architecture, right? And those types of things are your North Stars that you really anchor on, because it makes it easier to then go, hey, if I want to change again, and most of their customers laugh at me when I make the comment is, if you want to rip Dremio out in 5 years, for example, it shouldn't take you 5 to 10 years to do that. It should take you 1 to 2, right? And I think that's the piece of, like, if you're modernizing, a lot of the standards that we started establishing years ago, like, I want to be cloud first, but I know we're hybrid, right? Or I want to be an open architecture, but I'm okay going in and having vendor lock-in in these areas. And I think we're just doing less and less of the but part of it. And I think if you, as much as you can agnosticate that underlying piece of your architecture, it allows that modernization to go much smoother and faster. So, like, I've deprecated Teradata, for example, in 18-month window. When companies have worked on it for, before I joined, in 2 to 3 to 4 to 5 to 6 years trying to do it. And this is where, like, virtualization as the first step allows you to do stuff like that faster.
Migrations and modernizations are going on in every organization, because organizations are going through churn constantly. As business churn, as companies are bought and sold, as mergers and acquisitions take place, as companies reorganize. The data environment and the IT environments of every organization are in constant flux. It seems to me, being an analyst in this space for a long time, that data virtualization is always a capability that every organization needs in its hip pocket, because you never know when the next churn will happen in your business environment that will require you to stitch together a lot of disparate assets that you hadn't 6 months ago realized that you're going to need to stitch together. So virtualization is a perennial need. So
100%. And that's even if you talk about mesh or fabric, right? Like, everybody knows, like, that's kind of been in it and tried it. Fabric also is a North Star, right? Having everything fully connected to metadata catalog, to your entitlements, to centralized management and governance of all that, like, that stuff's hard. And it takes a long time. And I like to use my example, like, when I was at Zendesk, we had over 250 SaaS applications powering Zendesk. Who has that many connectors? And over 70 to 80% of those platforms were curating data, enriching data, cataloging data, and managing the governance of that data. And you're just like, that, just nothing, no tool in the world can connect all of that, let alone fast, right?
Right. Let me see here. Okay, so I'm going to move now to the audience Q&A portion of our program. Andrew, I'm going to hand it back to you. Thank you very much, Nick. So Andrew, take it away. I see a lot of questions coming in. Let's move to those.
Yeah, absolutely. And thank you both. That was a great discussion there. We do have quite a few questions. So most of these are, as you would expect, addressed to you, Nick. But Jim, of course, if you have something to add, please do so. So Nick, I'll start with this first one here. How does data virtualization integrate with various data sources, both structured and unstructured, and what flexibility does it offer in terms of data connectivity?
Yeah, so I think first and foremost, the use cases are always going to matter. right? So if you have a tool that can, for example, do virtualization with vectorized capabilities, that makes things a little easier. If you're running across a highly structured, highly integrated and enriched environment like a Teradata, right? And then interacting with data that's more unstructured in S3 buckets, but you at least have representation cataloging what types of data is in there, right? The performance, the integrations, all that jazz is going to take some hits, but the value is going to be there faster. And I think there's another element of here that I think was maybe combined with another question that I saw earlier, is there's actually better ways now to integrate that data. So classically, it's always like, hey, I have a JDBC driver, ODBC driver, or I have a general API integration strategy. And you're like, look, that can work, but it didn't, again, meet my performance needs. And one of the exciting things that pulled me over to Dremio is like the creation of Arrow, or Aeroflight more specifically. And I think tools like that is what really, in my mind, is fundamentally changing how you think about virtualization, or more specifically, even mesh and fabric, and delivering data faster, smarter to people. Which is, again, is why and Dremio donated that to open source community. I think we still see over like 50 million downloads of that tool. So what we're seeing is a better way to start integrating data, and then what the use cases are going to change how as a next step. So you can always pull data in. It's just the maturity of what does it mean to now treat that as a product or an asset. And I think that now changes how I would answer the next part of the question. Feel free to pop a follow-up in there if I didn't fully answer that one for you.
Okay, we'll move on to the next question here. Nick, how would you measure the performance of data virtualization compared to compared to data which will be implemented physically in databases? How would you measure the performance of this?
Yeah, maybe I'll use a fun example, and I won't name the companies that I've worked with and for. But I remember getting pulled into a room, I'll say midpoint in my career, and I got this massive document that somebody spent a lot of time on. And in that document, it was a list of, here's my SLAs, here's the uptime requirements, here's just kind of flow down as a full-on technical tech spec ask of my platform team. And within 5 minutes, we got to a quick point where I'm like, what's the thing you're trying to get accomplished? Don't ask me for technology. What's the business question? What's the driver? What's the impact of that? How often are you going to make those decisions, right? You don't need real-time data to be able to understand what your supply chain looks like on a long haul of like the actual go-to-market piece of that. It's geospatial data. I don't even need, I can miss runs as long as I don't miss 2 hops, right? Because as long as it went from the airplane to facility and into a truck, if I lose one of those, I know I'm still okay. So as you think about the business requirements, they need to drive the technical ones. So when you think about virtualization, you think about measuring it. It's like, well, what am I measuring? Am I measuring the quality of the data that I'm answering decisions off of? Great. Do I need insights, or do I need actually consistent 100% trusting data? If I need insights, I had this conversation yesterday with a prospect. Insights, I can have my data 30% wrong. I know enough of my data to make a proper decision or recommendation. But if you're making a financial report and it's part of your K10 and going to the street, that can't be wrong. So those things need to define and drive the requirements, which allows you to think about virtualization differently. In some cases, virtualization shouldn't happen, right? In that K10 example, what I need to be able to do is actually now move my data into a more consistent place to report off of. And that can be part of a larger virtualization strategy. As I combine that data and financial reports, for example, with new customers coming in, I can do a lookalike model, right? Or I can do these other advanced things with a lower SLA or OLA. So again, this is where I go back to like the use cases are always going to be key. And it's not the technical use case, it's the business. I don't know, Jim, if you have anything to add to that.
Yeah, actually, what you said relates to what we've seen for a long time in data governance. There's stringent data governance that's absolutely necessary for the data that you bet the business on, and clearly that's financial, that's customer, that's product, and so forth. And so you need to, in whatever environment you're running the business, a data environment, whether it be consolidated or virtualized, you need the ability to support disparate, as it were, grades of governance, from stringent to governance light, depending on the data set and depending on the use cases. So, a data virtualization environment then provides you with one fabric, a type of fabric within which you can, through all the various layers of capabilities like metadata management and the like, provide the relevant stringent and monitor the stringency of the governance in terms of lineage and so forth on disparate data sets, all at the same time, concurrently with each other. And so, in other words, a data virtualization fabric allows you to support these disparate use cases of data with side by side, and to monitor your ability to deliver these degrees of governance in real time. So, if you've architected your virtualization environment right, then you can have essentially federated governance over data sets that are growing in complexity, and use cases that are growing in complexity too. Things like you sort of alluded to earlier, like large language models for generative AI. To some degree, you need correct canonical from the source data to build and train these models. But a lot of the data that you're using that can be used to build and train generative AI models needn't be actually authentic data from the source. It can be synthetic data that conforms to the statistical profiles of whatever phenomenon you're trying to model here. So those kinds of data sets need a degree of governance, but it's really, the way I would define it, governance light. Not every record, or any record for that matter, may be an actual customer record. Let's say if you're doing like a next best offer capability in a generative capacity. What I'm getting at is that as you start to add more of these new use cases that may depend on synthetic data, on some level in your virtualization environment, you need to think, well, then I don't need to do by-the-book data governance on these data sets. But authentic customer data, you can't compromise on that. It's got to be correct, cleansed, consolidated, masked, and privacy protected, and so on and so forth, within a distributed environment, within a distributed within a distributed stewardship practice. So those are my 2000.
So I think that we go, So I think if we go back to the question on like the performance side, one of the first questions I ask folks when I do these workshops is like, what's your pain tolerance, right? Mm-hmm. Because to be clear, nothing we're going to do in virtualization is going to be faster than the data already being in Teradata. Right? It's fully optimized for answering that question. But that's not like we have a problem for a reason though. So the performance, the speeds and feeds are not always going to be the thing. It's what are you trying to get accomplished and what's that use case? And if I can deliver that to you 9 months faster, but instead of a dashboard loading in 1 second, it loads in 3, is that okay? Right? But it's not okay if it loads in 15. So those are the things of like understanding the pain tolerance with the impact that it then allows you to go, cool, if I want to bring it back down to 1, I can. But that's now when I'll do the modernization underneath the covers.
Okay, fantastic. We'll move on to the next question here. Is virtualization suitable for data curation for artificial intelligence or machine learning use cases?
Oh, great question. So I think theoretically, yes, right? And I think the engine that you're using to deliver that matters. So for example, like we have a lot of customers that use Dremio as part of the execution engine, right? And performance and being able to improve. So these are actually knowing it, powering data going into their Jupyter and Jupyter notebooks. So there's definitely a space there. I think the architecture is definitely going to matter though, as you get into the details. So I want to say yes, with my asterisk on there, depending on your architecture and maturity, it's an absolutely. The other side of that though, it goes again back to like, what's the use case too? So, because if you're trying to run a product recommendation through your website, or even what's the do I want to give a near real-time, high confident acceptance to somebody applying for a loan? What information are you pulling from, and how fresh is that information? And what's the risk tolerance, for example, to your bank? So all of those things are going to be continuously new data pieces and models built over top of each other that you need to be pulling from. And then it goes back to like, and to be clear, a user going through a digital application, especially on their phone, possibly sitting at a bus waiting to get to work, they want a near real-time experience and not wait more than seconds. So I think it has to pair the use case, and then the architecture also has to pair there too. So this is where it goes back to, depending on your architecture, it could be the second use case you go after, or maybe the 15th. But the answer is still yes.
Yeah, I agree. So data virtualization as an enabler for curation in an AI ML pipeline. Well, curation really fundamentally is related to data stewardship, which in this case, it's like the ability to, curation is the ability to discover the relevant data sets in a given domain. Say if you're building, let's say, a customer churn model, you need customer data. The ability then to profile and classify and tag those data sets so they can be used, for example, to train a customer churn model that meets, a certain requirement of accuracy in generating next best offer, or generating, recommendations about how to keep the customer from churning. So you can do all of that, data discovery, profiling, classification, tagging. All those curation functions can be performed just as well or as performantly in a data virtualization environment that's properly architected, as in, let's say, a unified, consolidated, say, data lakehouse. So, yeah, the data virtualization is a great real-time fabric for a lot of data curation that's necessary in an AI ML ops pipeline. We've seen that at TWDI in our research.
Yeah, and again, back to the architectural piece, because you look at something like a Dremio that has the ability to run virtual data sets then on top of a lake, which also protects a lot of your production-based data sources. Like I've been places and we've taken, Salesforce down just because we're pinging it too many times, right? So again, as you kind of think like, how do you optimize then the architecture underneath? That can then fully optimize all of your data science workflows. So again, like this is where I go back to architecture is also going to matter.
All right, we'll move on to the next question here. This one's from Abhishek. What are the key features in Dremio which enables organizations to leverage data virtualization?
So I appreciate the offer, and hopefully I come across as not pitching Dremio too much. So I believe in enterprise architecture as much as solution. But I think there's probably three things I'd highlight. One is just the acceleration side, right? Dremio, when it comes down point to point, you strip all the marketing and all of the stuff away, especially built on top of Arrow. We're frankly just faster than most of all of our competitors. Or we run at a lower TCO using capabilities like reflection, so those virtualized data sets. The other one is we kind of talk about is like Git for data. So we talk about data products, but treating data as a product. So, for example, with Dremio Cloud, using open source Nessie, which we created and open source to the community, being able to manage your lakehouse architecture and also think about things like, what's the life cycle of a data asset? So the two biggest breaches in my career were data scientists having to create their own data pipelines, come up with a model, and serving that to the business. And they used everything directly in the cloud. They just self-serviced all those things that we thought were governed. But a data scientist is not a data engineer. They don't think about sec DevOps. And we don't think about the maturity of those assets over time. So being able to have a Git for data type of experience where you can actually treat data the same way you would a product with version control, release management, and branching without having to actually even create your own and copies of data in curation. So a lot of really cool stuff in that space continuing to move out. And say in the last one is more of the flexibility inside Dremio. So a simple folder structure, for example, when you create your domain structure, I'll tell you, everybody that moves into data mesh, the way you start is not where you finish, right? And we all learn with things like abounded context, you need a lot of flexibility in how you think about your data ecosystem and your data hubs. So being able to just have a simple folder structure to navigate that, whether you're starting out organizationally, initiative, business lines, it's just very flexible to be able to immediately get value and start using the platform without having to set it up for months, if not years. Thanks for the question and the softball.
I should point out that Nick is referring to Apache Arrow. Of course, Dremio has built its platform on on Apache Arrow, which is a high performance, in-memory data analytics layer for virtualization environments. So
So,
well established.
Dremio, the two major parts of our ecosystem is Arrow and effectively Nessie, both of which were donated to the open source community. Our co-founders were extremely bullish on open architectures and open ecosystem, as little IP, frankly, as humanly possible.
Okay, fantastic. Well, unfortunately, this does bring us to the end of our time today, so please allow me to thank our speakers. We did, of course, hear from James Kobielus with TDWI and Nick Acheson with Dremio. Would also like to thank Dremio once again for sponsoring today's webinar. And from all of us here, let me say thank you so much for attending. This does conclude today's event.